Wind erosion accounts for about 40% of the soil loss in the United States, mostly in the western states. Other areas with wind erosion problems include muck and sandy soils of the Great Lakes states and Atlantic seaboards. The figure shows the amount of wind erosion for each state in average tons per acre per year for cultivated land. Dry areas with high winds are most likely to experience wind erosion. At greatest risk is soil kept bare by clean till summer fallow. I'm Dr. DeBusk, and in this video, I'll discuss the effects and factors involved in wind erosion and how to manage it. The figure shows the effect of wind blowing across a bare soil. A very thin layer of still air covers the soil surface, called a boundary layer, but larger soil particles stick up above the layer. When wind reaches 10 to 13 miles an hour at a height of 1 foot above the surface, soil grains begin to move. Saltation, or short bounces of fine sand, triggers wind erosion. Fine sands are large enough to protrude above the boundary layer, but small enough to be picked up by the wind. Surface creep and suspension both depend upon the impact of fine sand and saltation. Like water erosion, wind erosion removes the best soil first, the topsoil. It carries off fine soil particles, especially silt and organic matter. The shift toward a coarser soil texture reduces nutrient holding and water holding capacity. Furthermore, wind-blown soil particles sandblast young plants, tattering leaves and tearing away plant cells. Young plants can easily lose half their dry weight when exposed to sand-laden winds. Off-site damages can also be severe and expensive. Blowing soil can fill road or drainage ditches, affect the respiratory health of animals and people, increase cleaning and laundry costs, and wear at paint and other surfaces. The following factors determine the amount of wind erosion. Soil erodibility relates mainly to texture and structure. Soils high in fine sand and coarse silt are most liable to wind erosion. Soils high in clay are least liable. Drained organic soils are also easily eroded by wind. Soil grains cemented into stable soil aggregates are less likely to be blown away. Soil roughness makes a larger still air layer at the soil surface. Each clod or ridge also acts as a tiny windbreak to slow wind and capture blowing soil. Climatic conditions that promote wind erosion include low rainfall, low humidity, high temperatures, and high winds. Dry, windy conditions cause faster soil drying, and dry soil is more erodible than moist soil. Dry soil also supports a thinner vegetative cover. Length of field affects erosion. On the leading edge of a field, there is no wind erosion. As the wind travels across the field, it picks up more and more soil grains like an avalanche. Vegetative cover protects the soil, as does a mulch. Bare soil, on the other hand, is fully exposed to the erosive force of wind. These factors together can be arranged to create a soil loss formula similar to the Russell called the wind erosion equation, WEQ. According to the equation, erosion, E, is a function, F, of several factors, I times C times K times L times V, where I is a soil erodibility factor related to particle size, C is a climatic factor related to average wind velocities and soil moisture, K is a measure of soil roughness, L is field length, and V measures vegetative cover. WEQ is complex to solve, so will not be further detailed in this video. Preventing wind erosion means reducing the factors listed previously. The following practices help control wind erosion. Till at right angles to the prevailing wind, leaving the soil surface rough and cloddy. Lister furrows are very useful because they act as small windbreaks, called crosswind ridges, to capture blowing soil, such as in the top photo. Use conservation tillage or subsurface tillage tools such as rod weeders and subsurface sweeps to leave crop residues on the soil surface. Keep soil covered with vegetation as much as possible. Cover crops act as living mulches to hold soil in place and can reduce damage to plants by blowing sand, as in the crosswind trap strips in the bottom photo. Cover crops may also be used to protect soil over winter. Moistening soil with irrigation during windy conditions will temporarily hold soil particles in place. Plant windbreaks of trees and large shrubs as shown in the photo. Windbreaks protect soil for a distance of about 10 times the height of the break by shortening the field, reducing wind velocity, and capturing blowing soil. Lastly, plant the most critical areas to permanent grasslands or other vegetative cover. Two periods are critical for wind erosion. The first is when the soil is fallowed. Large, clean fallow fields in the Great Plains are ideal grounds for wind erosion. Subsurface tillage tools that leave crop residues on the surface reduce this problem. Instead of controlling weeds by tillage, herbicides can be used to kill weeds while leaving crop stubble standing to protect the soil from wind. The period between harvest and the following crop cover is the critical period in many areas. A good snow cover protects soil, but if the snow blows off the field, so will soil. Again, conservation tillage and winter cover crops protect soil during the critical period. Since climate is changing rapidly, many soil scientists are concerned that those technologies may be overwhelmed by climate change. Indeed, there's already some evidence of a quickening of erosion rates in some locations. For wind erosion, some parts of the world already prone to wind erosion are predicted to become even drier. Increased frequency of prolonged drought can only aggravate that problem, and if average temperatures in those same areas rise, soil will dry out even faster. The climatic factor C in WEQ will also be altered. This will put a strain on water supplies and may increase desertification on the soils. In conclusion, wind erosion is more likely to occur on soil that are high in fine sand or silt and in hot, dry, windy conditions. Control practices include breaking the wind, keeping the soil rough, and planting at right angles to the wind. The most effective method is keeping the soil covered by vegetation or crop residues.